So welcome to the presentation of SFTool with a special focus on the building decarbonization module. Now, share the screen. So SFTool. SFTool.gov in general is quite a large tool, and we're going to be focusing on some components of it today, especially the building decarbonization module. But SFTool as a whole is GSA's flagship sustainability website, and it provides critical tools for any team that is working on the built environment or buildings, as well as sustainable procurement. Now, when I talk about sftool.gov, we're talking about the full website that covers components from learning about general topics to planning projects, exploring buildings, procuring products and services, applying case study components of sustainable buildings, as well as train. I'm going to step you really quickly through each one of those before we focus on building decarbonization. I also want to acknowledge that SFTool also means the Green Procurement Compilation, where we talk about all the requirements or the rules that determine what counts as a sustainable product or service, regardless of which agency they come from. So we work very closely with EPA and Department of Energy and USDA for biopreferred when it comes to the GPC. And when it comes to the other component, SFTool product search, this is where you find all the products that comply with those rules. And we'll cover that too at the end of the conversation. So one thing to really be clear about is that the guiding principles for sustainable federal buildings underlie all of those best practices that we're covering today, whether we're talking about decarbonization or other things. Rather than lead with a whole bunch of language and words about what the guiding principles are, I wanted to just remind you about those top 6 ideas from integrated design and energy, water, and indoor environment, materials, and resilience, and let you know that, yes, we do cover the guiding principles in detail in SFTool as well. We also, when it comes to procurement, are very reliant on the federal acquisition regulations, something that I know that all of those on the call know already. But again, here, rather than lead with the lists of regs, what I wanted you to know is when it comes to the FAR, or it comes to the guiding principles, that links to the full text of both of those resources are integrated throughout SFTool so that you know where those regulations come into play. But what you're going to see today is the clearinghouse of the best information we've got as in the federal government for how to do these things and how to apply them. So rather than interacting with kind of text-heavy slides, we're going to be looking at pages like this. And this is a glimpse into the Learn section of SFTool. It covers things like climate, energy, water, and health. And we're going to dive deep into the climate section because that's where the building decarbonization module is found too. Before we do that, though, I'll give you a glimpse at plan. This is where that first column covers planning and engagement processes, things like building the right team, systems thinking, and integrative design. The second column of the plan section covers projects of all types. And the third column actually covers risk reduction and building resilience. Again, resources that you will find useful in SFTool as you access this site on your own. There is no login necessary to access SFTool. It's free, and you and your contractors and subcontractors can all use it. One of the things that makes SFTool accessible is really the way it uses pictures to give you a guided tour of actual sustainable choices in space. This is an example of the whole building view that covers building systems from lighting, water, and indoor environmental quality to workspaces, not only those in a typical office, but also things like laboratories. Wherever there's a green dot in SFTool, you can explore further. The Procure section is where we talk about 27 different product categories and 9 different service categories and the rules that apply for procuring those sustainable products and services. The apply and the train section are, as I mentioned briefly before, apply is basically case study central. It's the landing page for all things that come from the Interagency Sustainability Working Group. And the train section on the right here is a tool that allows agencies and individuals to understand what they need to know and find targeted training to meet the basic requirements of the Federal Building Personnel Training Act, a law that actually helps building professionals pursue professional development that benefits both them and the buildings they work in. So if that's any of you and you haven't found FMI, this is there for you. But what we're really talking about today is the building decarbonization module. And when it comes to this module, I will be joined with members of my team who are subject matter experts that actually wrote the content that you find in the building decarbonization module. That's how all of this content is actually created. Those folks include Dr. Kenneth Sandler and Walter Tersch from GSA, as well as Ann Jackson, Saif Sadek, and Don Horn from Noblus. And this section is all about how to reduce building emissions from building design, operations, maintenance, and procurement. And we'll have a time for questions at the end as well. So here's a glimpse into the landing page of building decarbonization. And we'll start with definitions. What is building decarbonization? Well, as it says right here in the middle, it's the process of reducing greenhouse gas emissions from buildings, including reduction of greenhouse gas emissions from the materials and products used in buildings, or embodied carbon, as well as from building operations, otherwise known as operational carbon. What I want you to see here is how you interact with the page. The table of contents there has jump links directly to all the different sections of this welcome page of building decarbonization. So we cover things like definitions of GHG and sources of greenhouse gas emissions and life cycle of carbon and total carbon, etc. We also have the two buttons at the bottom, embodied carbon and operational carbon, that take you directly to those subpages of this content. And our intent here, as with the rest of SFTool, is really to let you start with little to no knowledge of what building decarbonization is, and then dive deep into 200, 300, 400 level content, presenting this was a class, and actually get all the resources you need to actually execute and implement these ideas as well. So we'll be walking you through each one of those components over the next few minutes. So as I go to the next slide, I believe my colleague Ken will be talking about sources of greenhouse gas emissions.
Yes, sorry, it took a minute to unmute there. No worries. So I, expect and hope that all of you are, have a basic grounding in climate change and greenhouse gas emissions. You certainly need some of that for the reporting that you all do. I think a lot of the value of SFTool is in getting into the details and nuances that you really need to know, because as we've learned working for the government, the devil is in the details, and there's always a lot to know, sort of in the footnotes, so to speak. So so we go through a basic introduction on climate change, the effects, and the greenhouse gas emission sources, drawing from EPA and Department of Energy sources. The good thing in terms of this pie chart is greenhouse gases from buildings have actually gone down during the quarter century I've been working on this issue. But thanks to the work of people like you, making energy efficiency happen. But there's still a lot of work to do, because we need to get to zero, which is what decarbonization is all about. So in terms of, some of those nuances, I mean, for example, the SFTool, this page talks about the difference between carbon dioxide equivalent, CO2 and CO2e. carbon dioxide equivalent being where there's a mathematical equation, calculating methane and the different refrigerants and other greenhouse gases and kind of translating them into the same unit as basically as carbon dioxide. So carbon dioxide equivalent, CO2e. Because you'll notice when you're dealing with these data that sometimes there's little nuances. Sometimes they use this metric and sometimes they use a different one. So you want to be aware of that. So, for example, this page you can see talks about scope 1, scope 2, scope 3. Again, a concept I hope you're familiar with, but you need to dig into the details. Scope 1 being the emissions that are emitted on site from on-site operations. Primarily, that's burning fossil fuels, primarily for heating, and also water heating and cooking and other uses, but refrigerants as well. Scope 2 being all the emissions associated with all the electricity and steam and so on that you are purchasing at your building. Scope 3, the classic everything else category, and that's where we get into embodied carbon in the materials and products and services that you're purchasing, and a lot of other things, transportation and going to conferences and all that stuff, commuting. And of course the whole supply chain of where you're getting those products. So this is really, these sources are where we kind of unravel the whole issue of decarbonization, drawing from, on the one hand, the embodied carbon in materials, on the other hand, the operational carbon that you're dealing with every day in terms of operating your building efficiently, and as we'll get into, getting away from burning fossil fuels, getting away from leaking refrigerants, and getting more into use of clean electricity and renewables on site and so on. So I think that's about all I want to say on that issue.
Thank you. Did you also have?
Oh, yeah. Okay.
There you go.
Yeah, sure. So in terms of this page, again, getting into the details, I mean, I would think you all know, some of the basic goals of Executive Order 14057, Federal Building Performance Standard, et cetera. But it's really helpful to be able to just hop on and take a look and say, oh, yeah, that Federal Building Performance Standard has these criteria by which I need to rank buildings and figure out which third of my building square footage I need to electrify in the near term by 2030. So again, it's you can pop to these resources and find the details that you need. The devil being in those details, and that's where you will be evaluated in terms of guiding principles and all that. So thanks, Michael.
Thank you very much. Great. So now we have a very short video from SAFE.
Hi, my name is Saif Sadiq. I am Principal of Sustainability and Building Performance at Nobles, and I helped write the content for the total carbon section of the SFTool Building Decarbonization module. From here, scroll down, and here we are. Life cycle carbon / total carbon. So what is life cycle carbon or total carbon? It's the building's overall GHG emissions from cradle to grave, or from the design and pre-construction phases to the end of life phase. Life cycle carbon / total carbon is split into two categories, as you can see on the screen: embodied carbon and operational carbon. Embodied carbon refers to all of the GHG emissions associated with the manufacturing, transportation, maintenance, and disposal of construction materials, also known as the upfront carbon, whereas operational carbon refers to the GHG emissions associated with the operation of buildings, basically the energy used to operate buildings plus some other sources like waste generation and refrigerants. The sum of embodied carbon and operational carbon is total carbon. Thank you.
Excellent. Now we move to Don Horn.
Oh, hi, I'm Don Horn. I was with GSA for a long time and worked on SFTool for at least 15 years, but now I am assisting Noblesse, as was mentioned. So this slide says whole building life cycle assessment, but I think I need to take a step back and just explain a little bit about life cycle assessment in general. So life cycle assessment is a way to quantify the environmental impacts from material inputs and outputs over a product's life cycle. So in terms of inputs, that would be energy and water and raw materials that were mentioned, and outputs would be the product itself or service or building, whatever you're doing the life cycle assessment on. So you have the product, and then you have other emissions and impacts. So emissions to the air and water and other environmental impacts and waste as well. So to evaluate this, ISO standards and ASTM standards apply to give standard results here. And in this diagram that you see, those are the ASTM categories, I believe, for life cycle stages. And the front there to the left is the product stage, raw materials, the extraction and mining, and then transportation and manufacturing. That's frequently called cradle to gate because it's the gate of the manufacturer. They've produced a product, and when it leaves their gate, they really don't know how it's used or what happens next. But next would be the construction stage, the use stage. There's another part of embodied carbon that really is not necessarily included all the time, but it's end of life. It's something to think about, but for products in particular, you don't know what's going to actually happen at the end of the life. If a building is going to be deconstructed, if a material will be recycled or sent to a landfill, or how it will be disposed of. So there's much more uncertainty, but a lot of times there are general assumptions that are made to give the total carbon impacts here or analysis. So the whole building life cycle assessment is basically the same, but the product is the building. So it's all the components that go into making a building. So all of the life cycle assessments of individual products totaled together would be the whole building life cycle assessment. So as I mentioned with life cycle assessment, there are many different environmental categories that are evaluated, but we really have been focusing a lot on carbon, and that of course, is because of the contribution to climate change. So in the next slide here, I will go into some embodied carbon basics and definitions as well. So embodied carbon is about the upfront emissions for a building project. So that's from day one. As soon as you construct the building, you have the embodied carbon in the structure itself, in the building, everything that you put into the building. Operational carbon is over the life, at small increments over a longer period of time. About 1/3 or more of the total carbon is in embodied carbon. And as buildings become more efficient, high performance buildings, it's more like half or more of the total carbon is from embodied carbon. So embodied carbon is measured through global warming potential, and that is part of the LCA analysis. It's a material's total contribution to climate change. So the greenhouse gas emissions are compared to 1 ton of carbon dioxide, which would be carbon dioxide equivalents. You might have heard of that. Or frequently, we're just talking about carbon, embodied carbon, but it's really greenhouse gas emissions. And then there is an environmental product declaration. This is a standardized reporting tool to communicate a summary of the LCA impacts or results. And this is how we can start to do comparison between different products of the same category or whatever. So in that little snapshot there, it has a declared unit, a functional unit of 1 cubic meter of concrete at a certain strength. And so then you could look at other concrete mixes of the same and make comparisons between them through the environmental product declaration. So I'll stop there and pass it on to Walter.
Great, thank you, Don. So my name is Walter Tersch. I'm in GSA's Public Building Service and had the pleasure of working with Don over the past 2 or 3 years to develop GSA's groundbreaking embodied carbon and ByClean standards. So what are the components that go into embodied carbon? As Michael was showing at the beginning, it's really fantastic the way that SFTool has these nifty diagrams. It's little isometric projections that remind me of The Sims a little bit in terms of showing you the different components of our buildings and letting you click to zoom in. So you can see here, we've got tabs for both whole building and interior components. And on the whole building, you can see you can click to drill down for asphalt, insulation, roofing, the enclosure like glass and windows, and then structural materials. Structure and envelope are and if we go into structural materials, structure and envelope are very important because they're generally considered to be the largest contributors among a building's various components to the whole building embodied carbon. And of those structural materials, concrete and steel are often rightly pointed out as being some of the largest contributors to materials carbon. The only substance that humans use more of than concrete is water. It's the world's most widely used construction material and single-handedly responsible for about 8% of worldwide global emissions. So more than most countries in the world. The magic ingredient in concrete is Portland cement, which is the glue that holds together the aggregates and other components. And the cement also comprises over 70% of concrete's global warming potential footprint, or its GHG emissions. Concrete emissions come from both the manufacturing of cement as well as from chemical reactions and fossil fuel used to make that cement. So we do have nice strategies that are listed in under each one of these green dots, such as making sure that you're using the right size, the right amount of concrete, and optimizing the mix design to have the right amount of cement. Additionally, there's other strategies such as using supplementary cementitious materials like fly ash or slag that are also mentioned here in SFTool. This structural materials window also covers interesting materials like steel and wood and provides recommended strategies to explore to reduce the impact of those materials. Next. Switching gears a little bit to the interior view, you can see we also have pages. They provide information on everything from wood doors to the furniture, ceiling tiles, carpeting, aluminum, and then we'll zoom in and drill down a little bit to gypsum board, also known as drywall, because it's used throughout our buildings, used very heavily in pretty much any building of any type. So it's commonly used building finish, and it's inherently fire resistant, contains gypsum, which comes from mined or synthetic sources, but it's an energy intensive products to make. So the strategies that you can use to reduce the embodied carbon of your project's gypsum board is essentially making sure that you're not ordering too much, reducing the chance of things getting damaged during the construction process, and essentially trying to eliminate waste and use more lightweight building materials, more lightweight gypsum board. So with that, I'm going to pass it back to Don.
Okay, so how do we reduce embodied carbon in a building project? The first thing, of course, is to look at the big picture. So start with portfolio decisions. Do we really need to build? Do you need a new building? Can you make do with more efficient use of space? And then if you are going to build, are there opportunities for adaptive reuse? If you reuse a building or even components of buildings, materials, there is almost zero embodied carbon in those materials. If you're not doing any additional work, it is zero embodied carbon. It would only be the additional finishing or renovation that you need to do to that particular project. So that's your biggest opportunity for the greatest reduction in embodied carbon. Next, look at the design strategies. How can you reduce the area, the footprint of the project, or reuse components, just to right size all of this? And so that's where whole building lifecycle assessment tools come into play. There are several in the market that help you make general decisions about the structural system that you're using and other things and the impacts that they have on the total carbon of the building project. So yeah, in looking at the systems to optimize those for material efficiency. So should it be steel, concrete, wood structure, or something different? Looking at the envelope and the other interior finishes and things. So the shape of the building, all of these different decisions could contribute to lower embodied carbon. But then also to think about using bio-based materials. So not just wood, but other bio-based materials as well are on the market. And those are actually carbon sequestering. They are locking up carbon that is not being emitted to the atmosphere throughout the life of the building, as long as they're in the building. So that is a good way to reduce carbon. But also consider the mechanical, electrical, plumbing systems. Those are frequently overlooked, and even landscaping practices and how they can reduce carbon or sequester more carbon. Also consider building materials with extending the life of the materials. So if you don't have to change out interior finishes as frequently or other systems, then that is a good embodied carbon strategy. So then the last thing after you've considered all these larger impacts is to really, you know what you're going to build. So then you get to specifying those particular materials. So that specification and procurement is the last step, and it's frequently talked about the most. So actually, I think Michael is going to pick up on that now and talk about embodied carbon reduction through procurement.
Exactly. Thanks, Don. And it goes without saying that all the slides that we're sharing right now are actually directly lifted from sftool.gov, and there's lots more where that came from that connects the dots between each of these speakers. But I will say that when it comes to procurement of low embodied carbon materials and products, I will restate that it's after the thoughtful planning and design minimize the amount of materials a project needs that you actually source and procure products and materials with lower embodied carbon. And when you do so, you focus on what matters most. And how do we do that? We do that in terms of products by volume. What are the materials we use the most? Second, impact. What are the materials that have the highest quantity of embodied carbon that we buy for our projects? And third, hotspots. What are the points in the supply chain or a product's life cycle with the most significant environmental impacts? When it comes to procurement strategies that support decarbonization, I'm going to give a couple examples. The operational carbon that's actually used by some of the equipment in our buildings, like chillers, dwarfs the amount of embodied carbon involved in their manufacture and transportation to the building site. So we care about total carbon mattering most. On the other hand, tenant improvements occur several times within a building's life cycle. So while interior finishes and furnishings may not rise to the top of the list of the most carbon intensive products like concrete, asphalt, steel, and glass, items like gypsum board and flooring and furniture are typically purchased and replaced several times during a building's life cycle, which makes it very important to consider them when it comes to procurement. Thinking holistically and integrating whole building life cycle assessment at the earliest possible stages actually matters a ton, because it's the design and specification of what we're going to buy that is really critical when it comes to addressing embodied carbon. And also, don't forget about refrigerant selection when procuring items like cooling equipment and appliances. Refrigerants, as it says here, account for 2% of all global greenhouse gas emissions. And so we want to make sure that we're paying attention to those, not just the energy use of equipment, but also the refrigerant selection that those pieces of equipment actually employ. Okay, so next is Anne with case studies.
Thanks, Michael. Hi, everyone. I'm Anne Jackson, Principal for Sustainability and Building Performance at Noblesse. I helped write the content for several sections of the SFTool Building Decarbonization module. And I'm going to talk about the case studies, tools and resources that we've included for embodied carbon over the next 3 slides. So starting with case studies, we've included 5 case studies currently in the embodied, on the embodied carbon page. Each of these case studies provides some images, a description and details about the project, and includes the strategies employed to reduce embodied carbon and in some cases operational carbon as well. For embodied carbon, this includes building design strategies as well as material selection. Each case study has the title for each case study is a hyperlink that actually opens a new browser window and provides more information about each of the case studies. And the case studies included here represent both federal buildings as well as buildings that represent other sectors. So let's go to the next slide and talk about tools. So the tools that we've included for embodied carbon in the module break down into roughly 3 categories: design integrated tools, product selection tools, and embodied carbon calculators. Design integrated tools allow users to compare the environmental impact of materials and material assemblies from whole building designs, and in some cases can do this directly in a Revit model. That's the case with One-Click LCA and Tally. I do want to point out that most of the tools that we've included in the decarbonization module, both for embodied carbon and operational carbon, are free, publicly available tools. We have included a couple of tools that do require a license. That's the case for One-Click LCA and Tally, these 2 of the design integrated tools. That's because they are so robust and may be helpful for certain projects that you're pursuing. I will also note that Tally, though it does require a license, does allow a 10-day free trial for you to test it out to see if it's something that you would want to use. In terms of product selection, we've included the Embodied Carbon and Construction Calculator, or EC3 tool. This is free. Allows users to access published environmental product declarations, or EPDs, compare products and materials, and calculate embodied carbon reductions based on materials and material quantities that you input into the tool. And then finally, calculators allow users to estimate the embodied carbon of a building or a construction project. In some cases, this can be quite early in the design, which can be beneficial for making decisions very early on that can have a big impact. And calculators included here also allow comparing the impact of renovating a building versus replacing a building. And in every case, there are hyperlinks to, again, open a new browser window and take you directly to each of these tools and provide more information about their features and capabilities. And then next slide, we also have resources included here so you can get more information. Many of the resources that we've included come from the nonprofit Carbon Leadership Forum, which is a research center at the University of Washington. And they focus primarily on whole building life cycle assessment and reducing life cycle impacts. We've also included a resource here for purchasers, EPA's Sustainable Marketplace, which recommends specifications, standards, and eco-labels to help you identify and procure environmentally preferable products and services. We've also included a resource here from Building Transparency, which also provides the EC3 tool that provides more information on environmental product declarations and how to get one. Finally, I just wanted to highlight that we do have at the top of this resource list GSA's interim requirements for low embodied carbon construction materials if you want to find out more about those. And I am going to stop for now and turn it over to Walter, I think.
Thank you. Thanks, Ann. So we're going to switch gears back a little bit now from embodied carbon, which is to say emissions associated with the products and materials we buy, to operational carbon, which, as Michael and Ken laid out at the top, is also known as the scope 1 and 2 emissions associated with energy that we purchase, such as electricity or district steam, along with energy that we burn or materials that we burn directly in our buildings, on-site consumption. So operational carbon is obviously huge, and it's also something where you can see results immediately in your monthly utility bill. So we also have these nice diagrams for operational carbon. So you can click any of these green dots to see more information about best practices along with resources in terms of renewable energy, lighting. Want to learn more about energy storage and batteries? We got it. You click there, it links you to a whole new module that we have elsewhere that includes more information on energy storage. The two biggest, some of the biggest energy needs in a building include space heating and cooling, water heating, as well as lighting. So we're going to drill down a little bit here for the water heating, domestic water heating, and just show one example of what happens when you click one of these green dots. So you can see here, we're highlighting heat pump water heaters, which are a high efficiency way to transfer heat instead of generating it. The best traditional natural gas fired, methane powered water heater is usually around 95% efficient. Heat pump water heaters, 300% efficient is not unusual to see. So they can substantially improve energy efficiency over regular water heaters. And you can also include other strategies to save energy on water by making sure that you're using water efficient fixtures. Use less is conservation is always the first step to savings. So use WaterSense and Energy Star and FEMP designated products and plumbing fixtures. Make sure you're monitoring your water pressure to avoid excessive flow rates that would offset benefits of water efficient features, and make sure that your hot water pipes are insulated. We also link throughout these different component pages to resources that have been produced by other federal agencies, such as heat pump water heater pages on Department of Energy's website, EPA's WaterSense products page, as well as Energy Star and energy efficient product listings. And with that, I'll hand it to Ken to talk about more of the strategies to improve performance in these components.
Thank you, Walter. So moving from some of these specifics to a little more general strategies for operational decarbonization, and we get into a lot of specifics when you drill down. I think of it as a three-legged stool, but it's a four-legged chair here. The first leg being energy efficiency. I think the one that most of us are most familiar with, and certainly the government has made great strides in reducing, for example, the EUI, the energy use intensity, BTU per square foot, and all kinds of strategies. The SFTool has had a lot of material on this issue over the years. We tuned it up, so to speak, and added some. GSA has tons of experience with deep energy retrofits. We're getting like 40% energy savings from our retrofits. Metering is one of these strategies. Commissioning, all kinds of strategies. We don't have time to get into, but really critical stuff. Second leg, carbon pollution free. I think of carbon pollution free energy actually, including carbon pollution free electricity. But the key being switching from sources that produce carbon dioxide emissions or carbon dioxide equivalent, other greenhouse gas emissions, to those that don't. So that includes electricity, purchasing electricity from the grid that is produced from renewables or other non-carbon, non-GHG producing sources like nuclear, or operating your own, installing your own renewables, particularly solar, on-site wind in some cases where you have campuses. The second part of that leg, in terms of how I think about it, is building electrification, where you're replacing your on-site appliances and systems, particularly HVAC, also water heating and you know, kitchen cooking and so on, appliances with all electric, you know, and gaining the health benefits of not having the fumes from burning greenhouse gases on site, but also eliminating or reducing your greenhouse gas emissions by switching to electric. Building electrification is the one area I would say in all of operational decarbonization we need to do the most work on. We need to learn more. There's not a lot of good case studies and so on in the private sector, and so particularly on how to do it cost effectively. So so we're working on that, but we incorporated what we have. Obviously, a big strategy is using heat pumps, and so you know, so we focus on that. And the final part, not shown here, but the final leg, building and grid integration. And this is an area, a topic that I think a lot of people don't focus on, don't understand, don't appreciate. It is absolutely critical to decarbonization, both from the end of the building and from the other end of the grid, the entire electrical system. In terms of the electrical system, we are, if we're going to transition as we are from burning fossil fuels to you know, carbon pollution free electricity, we will need a more responsive integrative system. You know, for example, the fact that the sun does not shine at night and the wind is not always blowing. We need a more flexible system that incorporates building or system storage, energy storage. We need smart grid, smart buildings, smart appliances that all talk to each other and give the building people credit for reducing their energy use, as well as for producing energy on site through renewables. So I'm proud to have developed a page on building and grid integration, and I hope everyone looks into that issue. There's a lot of strategies, and also you can save a lot of money because the electric rates are increasingly driven by demand charges, where you pay more based on your highest demand periods of your electric billing cycle. So reducing those loads, shaving off those peaks really can save a lot of money, as well as saving the electrical system a lot of stress as we, you know, try not to increase the load too much as we're electrifying, you know, but also doing building and grid integration. So there's a lot here on all of these strategies, really drilling down. You can drill down as far as you like. And yeah, I think that's the basic overview.
All right, so the next 3 slides are going to look somewhat familiar. I'm going to talk about case studies, tools, and resources for operational carbon. Like with the case studies for embodied carbon, we have several case studies here representing different building types, different sectors. There are 4 operational carbon case studies included. Each one is going to include some imagery, a description and details about the project, including the strategies employed to reduce operational carbon, and in some cases, embodied carbon as well. For operational carbon, this includes building orientation, envelope design, mechanical systems, and energy sources. And again, each case study title is a hyperlink allowing you to go to another page to get more information about the case study. Next slide. Next, operational carbon tools. There are also 3 categories of tools that we've included. They're different categories than for embodied carbon. The categories are data analysis tools, procurement tools, and operational performance tools. The data analysis tools really allow users to input data about their building energy, or in some cases, water, and estimate, track, and manage performance, identify cost savings, and research and resource efficiency opportunities. In terms of procurement, Enable is an energy savings performance contract, or ESPC program, that assists federal agencies in procuring an ESPC to implement energy conservation measures, such as lighting and water fixture upgrades, replacing HVAC equipment, installing HVAC controls, and solar photovoltaics. The Enable program does also include a selector tool to help users build a notice of opportunity. And then in terms of operational performance tools, there's tools here that allow users to identify energy savings opportunities and operational improvements, tools to compare energy technologies, compare retrofit scenarios, and calculate the impact of renovating versus replacing a building. And again, hyperlinks take you directly to each of these tools so you can get more information. And then next slide, talking about resources for operational carbon. The majority of the resources included here come from the Department of Energy and provide information about energy efficiency, CFE, metering, energy management and information systems, commissioning, HVAC, water heating, a lot of the things that you've heard Walter and Ken talk about that are provided in terms of overviews in the tool. There are also resources from nonprofits like the New Building Institute and Rocky Mountain Institute related to ways to effectively retrofit commercial office buildings, as well as what it means to be a carbon neutral building. And there's also included here a GSA net zero energy study that includes recommendations for cost-effective energy conservation measures that GSA is applying to its portfolio of buildings to reduce operational source energy in order to get to net zero, assisting in achieving the federal government's sustainability plan goals. So I am going to stop there and turn it back to Michael.
Well, thank you. And thank you, Ken and Walter and Don and Anne for joining us today.